Good morning, all of you. Today we are going to discuss the plane and various forms of the equation of a plane. My voice is audible. Okay, the topics of this chapter is objectives, then 2.1 is introduction and its a definition of a plane, equation of a plane, and different forms of an equation of a plane. Then 2.4 is length of the perpendicular from a point to a plane and system of planes, worked on exercises and summary, check your progress and model of these answers. Okay, first we have to discuss the objectives of this chapter. What are the objectives of this chapter? So obtain the equation of a plane in its general form and various forms of the equation of a plane. Then determine the angle between the two given planes. So determine the length of the perpendicular from a given point to a given plane. So that means the distance from one point to another point, the distance between 2 points. And we know the definition of the distance between 2 points and the root of x2. Let P be a point on the plane and O is the origin of the coordinate axis. It's a distance from origin to P. Under root of x2 minus x1 whole square plus under root of y2 minus y1 whole square. That is the distance between 2 point formula. Then find the equation of the system of planes through the line of intersection of the plane. This is the objective of the chapter. So what is the introduction? So a plane is a surface on which if the 2 points are taken on it, then the line joining them linely wholly on the surface. The angle between the two planes in terms of direction ratios of their normals. Already we have discussed in previous topic direction ratios and direction cosines of the plane. So now definition of a plane. What is a plane? A surface is called a plane surface or a plane of all the points of a straight line joining any 2 points on the surface lie on it. For example, let OA and OB be the two intersecting lines. OA and OB be the two intersecting lines. For example, this is a point and this one is O and this one is A. OA and OB with the two intersecting lines. So this is a coordinate axis OA and OB. Call it as, for example, this is a B with the two intersecting lines. These are the intersecting at point O. Let OA and OB be the two intersecting lines. The set of all points P such that lambda OP can be written as lambda of OA plus mu of OB constitutes a plane. Now, an equation of the plane is a relation satisfied by the coordinates x, y, z of every point on all. Let x comma y comma z be the, we are discussing 3D geometry and there are x-axis, y-axis and z-axis. X-axis, y-axis and z-axis. This one is x and this one is y and this one is z. The intersection of these three is called origin. Called as this one as origin of the x, y, z. So every equation of the first degree in x, y, z represents a plane. What is a plane? Every equation of the first degree in x, y, z represents a plane. Consider a general first degree equation in x, y, z as ax plus by plus cz plus d equals to 0. This is a general form of a first degree equation of a plane. Where what are the a comma b comma c comma d are? These are real numbers In this equation, a comma b comma c are coefficients of x, y, z. So these coefficients are belongs to real numbers and all are not equals to 0. For example, if either a equals to 0 or b equals to 0 or c equals to at least one of them is 0, we get 3D geometry to 2D geometry. One coefficient is equal to 0, then one variable is disappears. Ax plus by plus d equals to 0, then 3D geometry to is a 2D geometry, becomes a 2D geometry. Therefore, where a comma b comma c are real numbers and not all 0, that means all are not equals to 0. If this condition is satisfied, so square sum of squares is also not equals to 0. To show that one represents in the equation of a plane, we have to show that every point on the line joining the point on the focus and the locus of one is also lies on the locus of one. Now let there are 2 points. Let P of x1, y1, z1 and x2, y2, z2 be any 2 points on the locus of equation 1. Locus of a given equation is nothing but equation of a plane. Then we are substituting P into equation 1, ax1 plus by1 plus cz1 plus d equals to 0. Here d is a constant term. Then point Q substituting equation 1, we get ax2 plus by2 plus cz2 plus d equals to 0. Then these are the equation number 2 and 3. So let R be any point on the segment joining these 2 points. Suppose R divides PQ in the ratio lambda is to 1. For example, this is a 1 point. Let P comma Q be 2 points is a line. For example, this is a line. Here, this is a point P and this is point Q. Let this is a point R. R divides PQ in the ratio lambda is to 1. Lambda is to 1. Lambda is to 1. So let R be any point on the line segment. Actually, what is a line segment? It has a 2 end points. Line segment means the 2 end points of the segment is called a line segment. For example, diameter of this circle is also a line segment. What is a ray? Starts from one point to another extends up to infinite. This is called a ray. Straight line means extending 2 points, 2 sides of the line. So we are extending up to infinite from P side and from Q sides. We get a line segment to is a straight line. So R divides PQ in the ratio lambda is to 1. Now then R equals to, we know the external formula, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Here m is a lambda, m is to n. M is to n means m is a lambda and 1 is n. We get a formula mx2 plus nx1 by m plus n, comma m by2 plus ny1 by m plus n, comma nz2 plus nz1 by m plus n. Here lambda plus 1 is not equals to 0. That means if lambda equals to minus 1, we get lambda, its denominator, the point R denominator is lambda equals to minus 1, we get 1 plus minus 1 equals to 0, is undefined. That's why it's a sum, lambda plus 1 is non-zero. So we get a R point. The point R divides the segment PQ in the ratio lambda is to 1. Therefore, multiplying equation 3 by lambda, adding equation 2. Adding to equation 2, we get A of, we are multiplying lambda by equation 3. A lambda x2 plus B lambda y2 plus C lambda z2 plus D lambda 2 equals to 0. Either lambda, we are multiplying with lambda. So A lambda x2 plus B lambda y2 plus C lambda z2 plus D lambda equals to 0. And adding this equation to equation 2, we get A lambda x2 plus ax1 plus b lambda x2 y2 plus b lambda y1 plus c lambda z2 plus cz1 plus d lambda plus d equals to 0. So we are separating the coefficient of a and coefficient of b and coefficient of c plus coefficient of d equals to 0. A into lambda x2 plus x1 plus b lambda y2 plus lambda y1 plus c lambda z2 plus z1 plus d of lambda plus 1 equals to 0. We are dividing this equation by lambda plus 1. A of lambda x2 plus x1 by lambda plus 1 plus b of lambda y2 plus y1 by lambda plus 1 plus c of lambda z2 plus z1 by lambda plus 1 plus d equals to 0. Now, what is the R? This shows that the point which is in the form ax2 plus, this is a general form of a plane equation. A some, this can be written as some k1, a k1 plus b k2 plus c k3 plus d equals to 0. Here in place of x we are taking k1, in place of y we are taking k2, and in place of z we are taking k3. Now this equation becomes a k1 plus b k2 plus c k3 plus d equals to 0. This is also a general form of a plane equation in terms of k1, k2, k3. So what is K1? K1 is the point lambda x2 plus x1 by lambda plus 1. And K2 is lambda by 2 plus y1 by k lambda plus 1. And K3 is lambda z2 plus z1 by lambda plus 1. So we get a general equation in terms of other. So this shows that the point R of K1, comma K2, comma K3 lies on the equation 1. What is the equation 1? General form of a line equation. General, this one is the This one is the general form of a plane equation. Okay, ax1 plus by1. This is actually okay. Now, this shows this lies on the equation 1. For every lambda is not equal to 0. Therefore, R is an arbitrary point on the line which is joining P and Q. Every point on PQ lies on equation 1. So, every point of PQ, that means every point on the line segment is also lies on the general equation of a plane. What is the general equation of a plane? Ax plus by plus z plus d equals to 0. Therefore, the surface given by the equation 1 represents a plane. This is the meaning of this equation of a general form of a plane, which is surface of a given equation represents a plane. So now this is the general form. Ax plus by plus cz plus d equals to 0 is called the general equation of a plane. Okay, this is the node point where r is the radius of the point, radius of the circle. Then what is the equation of a plane passing through the point x1, y1, z1 is of the form a of x minus x1 plus b of y minus y1 plus c of z minus z1 equals to 0. And this is the corollary. We have to prove this. We have to take first general form of an equation of a plane. What is that? Ax plus by plus cz plus d equals to 0. Let any point p of x1, comma y1, comma z1 be a point on the plane. Okay. Now we are substituting this point into this equation ax plus by plus z plus d equals to 0. Then the equation 1 becomes ax1 plus by1 plus cz1 plus d equals to 0. So after writing the constant d equals to remaining equation minus ax1 plus by minus of this one, we can written as d equals to minus of ax1 plus by1 plus cz1 plus d1. So substituting d value in this equation, what is the equation? Ax plus by plus cz plus d equals to 0. Here in place of this, actually we know that in place of this d equals to 0. Okay. After substituting d value from equation 2, we get this equation ax plus by plus cz minus of ax1 plus by1 plus cz1 plus equals to 0. So ax minus ax1 plus by minus by1 plus cz minus cz1 equals to 0. So a of x minus x1 plus b of y minus y1 plus c of z minus z1 equals 0, which is the required equation of the plane passing through the points x1, y1, z1. Okay. And this is the equation. The equation of a plane passing through the point x1, y1, z1 is of the form a of x minus x1 plus b of y minus y1 plus c of z minus z1 equals to 0. This is the required equation of the plane passing through the point x1, y1, z1. Now, what is the note? In particular, the equation of a plane passing through the origin is any equation of a plane passing through the origin is nothing but its coordinates x, y, z coordinates are x, y, z coordinates are 0, comma 0, comma 0, comma 0, 0, comma 0, comma 0. Its coordinates x comma y comma z coordinates are 0. X is 0, y is 0, z is 0, because origin is nothing but its coordinates are 0, 0, 0. After substituting this coordinates 0 comma 0 comma 0 into standard form, what is the standard form? General form of a plane equation is ax plus by plus cx, or ax plus by plus cz plus d equals to 0. After substituting x, y, z values in that equation, we get d equals to 0. D equals to 0. Okay, d equals to 0. So we get a d value. After getting d equals to 0, then substitute again d value in that equation 1. What is the equation 1? Ax plus by plus cz plus d equals to 0. After substituting d value, we get this equation only. What is that equation? Ax plus by plus cz equals to 0, which is nothing but the equation of a plane passing through the origin is ax plus by plus cz equals to 0. This is the meaning of this one. Now, okay, now general form of a plane equation is completed. Then what is the normal form? Normal form of a equation of a plane. So normal form of a equation of a plane, same procedure, same manner. What is the general form? Normal form of an equation? Lx plus my plus nz equals to p. This is the normal form of a equation of a plane. This is again written as the equation of a plane. ABC is, what is ABC? Is a triangle, is a plane. ABC is nothing but is like showing like a triangle or is a plane. Okay, this is a procedure you have to read. And this is P of x y z be any point in the plane, join OP and OK, then OK is a projection of OP and OK itself. So this is a common procedure. That is not a mandatory. You have to remember this formula. What is the equation of a plane in normal form? Is Lx plus my plus nz equals to p. The equation of a plane in normal form is this one. This one is the normal form, and this is the equation of a plane triangle ABC is Lx plus my plus nz equals to p. Thus, the equation of every plane is of first degree only. We are discussing only first degree equations only. Okay. It, what is the degree of this equation? Is the power of the powers of coefficient variables. What are the variables? X, y, z are the three variables. These are the variables. The powers of x, y, z. Here x power is 1, x power is 1, and y power is 1, and z power is also 1. It represents the equation is in first degree only. So now these are the note points. The important points: Lx plus my plus nz equals to p is called the equation of a plane in normal form. This is a normal form. What is the difference between normal form and general form? So in general form, in place of L, here ax plus by, ax plus by plus cz equals to d. Equals to d. Here, what are the a comma b comma c comma d are? Actually, here in place of general form, here plus equals to 0, but in normal form equals to p. This is the main difference. And one more difference is there. What are the a comma b comma c comma d? So here a comma b comma c are direction ratios discussed in previous chapter or previous lesson. Here a comma b comma c are constants, is nothing but dr's, direction ratios of the line. Here d is the general common constant, we call it as a constant. What are the L comma M comma N? L comma M comma N are direction cosines of the plane. So that's why this is a major difference between general form of an equation of a plane and normal form of a equation of a plane. Okay, P is a perpendicular from plane to line. Now Lx plus My plus Nz equals to P is called the equation of a plane in normal form. And an equation Lx plus My plus Nz equals to P is in normal form if this equation is in normal form and this condition is holds. L square plus M square plus N square equals to 1. This is true. But A square, A square plus B square, A square plus B square plus C square, C square is not equals to 1. Is not equals to 1. Why? Because these are the direction ratios of the plane. These are the direction cosines of the plane. So that is the major difference. This is the one difference and this is the another difference. If an equation is in normal form, it satisfies this condition. L square plus M square plus N square equals to 1. Actually, what is the L? What is the L? What is the L? L is nothing but plus or minus a by under root of summation a square. Summation a square. What is the summation a square? Is nothing but a square plus b square plus c square. Here L equals to plus or minus a by under root of summation is nothing but sigma summation a square. What is a summation of a square? Is nothing but coefficient of x square plus coefficient of y square plus coefficient of z square. Now L equals to this one and M equals to plus or minus b by summation. Denominator is same for all. L comma N comma N. It's all denominator is same. Here M equals to plus or minus b by under root of a square plus b square plus e square and n equals to plus or minus c by under root of summation a square. Okay. Now we get L square plus M square plus N square concept. What is L square? L square is nothing but plus or minus whole square is always positive. We get a square. Denominator is same for all. Under root of a square plus b square plus e square. Here squaring on both. L square is nothing but a square by L square plus M square plus N square by a square plus a square plus b square plus c square. So denominator is common for all L comma M comma N coefficients. Okay. L square, a square by a square plus b square plus e square. And M square, what is M square? Is plus or minus root plus or minus b. That means plus or minus its whole square is always positive. So M square always b square by this denominator. What is the N square? Plus c square by a square plus b square plus c square. Okay, this is L square, a square by this fraction, denominator, and M square is b square by same, a square plus b square plus c square, and N square is c square by a square plus b square plus c square. After cancelling numerator and denominator, both are same, numerator and denominator both are same, we get equals to 1, which is the we get RHS value. After substituting LHS value, we get RHS. Therefore, if an equation Lx plus My plus Nz equals to P is in the normal form, so it's satisfying this condition L square plus M square plus N square equals to 1. Do you understand the difference between A and L? A is the direction ratio. We can written as A only. That means the difference of 2 points. But in place of L is the plus or minus a by under root of a square plus b square plus c square. That is the difference between A and B. That's why we call it as A is the direction ratio and LMN are direction cosines of the plane. So now translation transformation of a normal form. Okay, we get in already we discussed what is L. L is the plus or minus A by what is A? A is a plus or minus A by A in the root of A square plus B square plus C square. Now what is the M? Plus or minus B by under root of A square plus B square plus C square. Now what is the N? Plus or minus C by under root of A square plus B square plus C square. Okay, if element are direction cosines, already we discussed direction cosines. These are the direction cosines satisfying this condition L square plus M square plus N square equals to 1. What is a P? P is always positive. P is a perpendicular distance from point to the line or plane. This is a P is always positive as a P is always positive. We get a L value, M value, N value. After substituting L, M, N values, we get equation L square plus M square plus N square equals to 1. This is a standard form. Then substituting all the values L in place of L, we are substituting plus or minus A by this one into X plus or minus M y plus or minus N values plus or minus C by this one Z equals to P. What is the P? Plus or minus D by under root of A square plus B square plus C square. Now separating each and every term A by this one plus B by root of summation A square of Y plus C by root of summation A square into Z equals to minus D by summation root of A square. If D is negative, there are two possibilities. One is positive condition and another one is negative possibility. So if D is negative, we get minus of D. If D is positive, we get D by root of summation A square, where summation A square stands for this one, A square plus B square plus C square. What are the note points? There are some remark points. The direction ratios of the normal to the equation, normal to the plane are, what are the DRs? A comma B comma C are DRs. Now AX plus BY plus CZ plus D equals to 0. Already told you A comma B comma C are direction ratios. We get a equation of a plane. If L comma M comma N are DCs of a plane, we get a normal form of a plane equation. That is Lx plus My plus Nz equals to P. And this is A comma B comma C are DRs. We get general form of an equation, plane equation. Ax plus By plus Cz plus D equals to 0. Here ABC are the coefficients of x, y, z. A is the coefficient of x and B is the coefficient of y and C is the coefficient of z. Now, second note point is from equation 3 to this one, perpendicular distance from origin to. What is the perpendicular distance from the point origin to the point is Ax plus By plus Cz equals to D by under root of A square plus B square plus C square is nothing but is a perpendicular distance from origin to, okay, perpendicular distance from origin to the plane is A into 0, A into 0, actually A into 0 plus A into 0 plus B into 0, B into 0 plus C into 0, C into 0 minus D. So plus D is nothing but plus D by plus D modulus by its denominator is summation root of summation A square. Root of summation A square. You get A into 0, 0, B into 0, 0, C into 0, 0, plus D by is nothing but equals to modulus of D by this one, root of this value. Okay. We are removing its modulus. We get a two values. One is a positive and another one is negative. So plus or minus D by plus or minus D by root of summation A square. root of summation a square. Okay. Why we are putting plus or minus? For example, d is positive. Modulus of d is also positive. If d is negative, its modulus is also negative. So after we are removing this modulus, we get plus or minus values. So that's why. So the equation of this one is a perpendicular distance from origin to the plane is plus or minus d by under root of a square plus b square plus c square. And we know that every distance is always positive. So we are not taking non-negative. That's why d by under root of a square plus b square plus c square is the perpendicular distance from origin to the plane. Okay, here given one example, find the direction cosines of the normal to the plane. So here, what is the comparing this with the standard form? In general form is ax plus by plus cz plus d equals to 0. What is the coefficient of a is 1, coefficient of b is 2, and coefficient of c is 2, coefficient of d is minus 4. Here coefficient of a is 1, b is 2, c is 3, and d is minus 4. Therefore, d is minus 4, which is less than 0. So the direction cosines are, what is the L? A by under root of a square plus b square plus c square. 1 by under root of 1 plus 4 plus 4. We get 1 by root 9 is 1 by 3. Next, m equals to b by, m is b by same root of denominator values 3 only, 2 by 3. We get 2 by 3. What is the c? C is, n is c by 3. So 2 by 3. We get L value is 1 by 3 and M value is 2 by 3 and N value is 2 by 3. So what is the condition? If these are correct or not, we are checking. The condition is if L comma M comma N are DCS of the given plane, it satisfies the condition L square plus M square plus N square equals to 1. Okay. L square is 1 by 9. 1 by 9. So its denominator is 9 for all. Okay, 1 by 9 plus m square. What is m square? Is 2 by 3 whole square. 2 by 3 whole square is 4 by 9. So numerator is 4 by 9 plus n square value. What is n square value? N square is also 2 by 3. Okay, we get a 4. Again 4. Okay, 1 plus, okay, 1 plus m square is 4. 2 square is 4 plus n square value. What is n square value? Is also 4. Is also 4 by 3 square value is 9. 4 plus 4 plus 1. What is the 4 plus 4 plus 1? Is a 9. And that means 9 by 9 is equals to 1. Therefore, L square plus M square plus N square equals to 1, satisfying this condition. Why? Because L comma M comma N are DCS of the given plane. Okay, next example, the perpendicular distance from origin to the plane is, we have to find the perpendicular distance from origin to the plane. What is the origin to the plane is d by under root of a square plus b square plus c square. What is the d? Here a is 3, a value is coefficient of x3 and b value is coefficient of y4 and c value is coefficient of z minus 12. So d value is 65. D value is 65. So a value is 3 and b value is 4, c value is minus 12 and d value is 65. So a by, sorry, d by perpendicular distance from origin to the plane is d by under root of a square plus b square plus c square. So 65 by 9 plus 16 plus 12 square is 144. 65 by 169. Root of 169 is 13. 13 ones are 13 fives are. We get 13 ones are 13 fives are. We get 5 only, which is the required perpendicular distance from origin to the plane. So the distance is 5 centimeters. Now, reduce the equation, this one of the plane to the normal form. Okay. What is the normal form? Is the normal form is the equation of a plane is Lx plus My plus Nz plus, this is actually general form, Ax plus By plus Cz plus D equals to 0. We have to convert this equation into normal form. What is the normal form? Lx plus My plus Nz equals to P. Okay. Now we have to convert this one. You have to reduce the given equation to this form: Lx plus My plus Nz equals to P, where what is L? A by under root of sigma A square, B by under root of summation A square, C by under root of summation A square, and P is minus D by summation A square. Why? Because we get P is a plus or minus values, but here D is negative, so P taken minus of D value. Okay. L value is 1 by root 14 and M value is B by root of value is root 14, N value is minus 3 by root of 14. So P value is 6 by root 14. Substitute all the values L comma M comma N comma P values in this equation. In this equation we get L value is 1 by root 14x, 1 by root 14x, L value is this one, and this one is L value. This one is L value is 1 by root 14x, M value is 2 by root 14y, and N value is minus 3 by root 14z, and this is a P value 6 by root of 14. So Lx plus My plus Nz equals to P, which is the normal form of a given equation of a plane. This is a concept of general form of a plane equation and normal form of a plane equation. Now, the next concept is angle between two planes. Angle between the two planes. So, for example, any two lines. Now, first, we are discussing angle between the two lines. There are two lines. Okay, there are two lines intersecting at this. Okay, at point P. So now, to form an angle, here one more angle, and this is one more angle, and this one is one more angle. There are four angles based on observer perspective. There are four angles forms. Any two lines are intersecting, we get a angle. So similar way, so any two planes are intersecting, intersecting. Okay, you get the angle formation. And we know that the coordinate axis, the vertical line is called y-axis and the horizontal line is called x-axis, and this one is x, this one is y. The intersecting of two lines. These are the coordinate axes. The angle of first quadrant is 90 degrees. Both are perpendicular. So x-axis, y-axis are always perpendicular. This is called coordinate axis. This is the first coordinate. Its angle is 90 degrees. And second coordinate, every quadrant angle, the angle between x-axis and y-axis is 90 degrees. That means two lines are perpendicular to each other. Its angle equals to 90 degrees. A similar way, the angle between two planes. What is the definition? The acute angle between two planes is defined as the angle between their normals. What is an acute angle? So what is an acute angle? Acute angle of a two planes. The acute angle is nothing but any angle value lies between more than 0 and less than 90. That is called an acute angle. And an angle lies between 0 to 90 degrees, strictly less than, not an equal to 0 case and not an equal to 90 case. This is the acute angle definition. So the angle lies between, strictly lies between more than 0 and less than 90 is called an acute angle. Now, the acute angle between two planes is defined as the angle between their normals. What are the equations? So a1x plus b1y plus c1z plus d1 equals 0. These are the two plane equations. General form of a plane equation. Let be two planes. Two planes. The two planes means we are changing coefficients of x only. X, y, z are same. The variables are same, but their coefficients are different. Here A1, B1, C1 plus D1 indicates the equation of a first plane, and A2x plus B2y plus C2z plus D2 indicates this equation of a second plane. Then the direction ratios of the normals. These are the direction ratios A1, B1, C1 and A2, B2, C2 respectively. The angle theta between the planes, angle between their normals is cos theta equals to cos theta. This is the important formula. You have to remember this one. Cos theta equals to plus or minus a1 a2 plus b1 b2 plus c1 c2 by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Okay, if the condition for parallelism and perpendicular of two planes. For example, these two lines are parallel. What is the condition? If these two lines are parallel, is there any intersecting points? There is no intersecting points between these two lines. So we get there is two lines are intersecting, then angle is formed. If two lines are parallel, its angle equals to 0. Therefore, cos 0 value is substituting theta equals to 0, we get cos 0. Cos 0 value is 1. Cos 0 value is 1. By multiplying both sides, by cross multiplying, we get a1 square root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c square. After simplifying this one, we get, after simplifying this, we get, these are the parallel condition. So what is the parallel condition? The two lines will be parallel if the normals are is in the condition a1 by a2 equals to b1 by b2 equals to c1 by c2. If two lines are perpendicular, what is the perpendicular condition? If two lines are perpendicular, perpendicular means already discussed earlier. What is the perpendicular? Two lines are perpendicular. For example, coordinate axis x and y axis are perpendicular. Theta equals to 90 degrees. What is the theta equals to? 90 degrees. If this angle is 90 degrees. Cos 90 is 0. This one by cross multiplying, we get denominator into this 0 is, we get a 0. 0. So a1 a2 plus b1 b2 plus c1 c2 equals to 0. This is a perpendicular condition. Parallel condition is coefficient of x coefficients, ratio of x coefficients of first and second lines equals to ratio of y coefficients of first and second lines, second planes, and equals to coefficients, ratio of coefficients of z. So a1 by a2 equals to b1 by b2 equals to c1 by c2. So this is a parallel condition and this is a perpendicular condition. Now this is one example. The angle between two planes. Write down the angle between two planes. So the angle between the two planes is 2x minus y plus 2z minus 3 equals to 0, and 3x plus 6y minus 2z minus plus 2z minus 4 equals to 0. These are the equations of two planes. Here what is a1, b1, c1 and a2, b2, c2. Here a1 value is 2, b1 value is minus 1, c1 value is 2, and d1 value is minus 3. So here no need to write d1 and d2. We need only a1, b1, c1, a2, b2, c2 are enough. So a2 value is 3 and b2 value is 6 and c2 value is 2. So what is the formula? Cos theta, the angle between two planes cos theta equals to a1, a2 plus b1, b2 plus c1, c2 by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Now cos theta equals to a1 into a2, 2 into 3 is 6, and b1 b2 minus 1 into 6 is minus 6 plus c1 c2, 2 into 2, so 4. 6 minus 6 plus 4 by root of 9 into root 49. So 3 into 7. We get 4 by 3 into 7. So 4 by 21. This is a cos theta value. But we want to theta only angle between the two planes. So theta equals to cos inverse of. Now cos, it becomes cos inverse of 4 by 21. This is the angle between given two planes. This is one more example. Show that the plane is perpendicular to the plane. So plane is perpendicular to the plane. What is the condition? A1, A2 plus B1, B2 plus C1, C2 equals to 0. This is already we discussed the formula A1, A2 plus B1, B2 plus the two planes are perpendicular. Two planes are perpendicular. This is the condition A1, A2 plus B1, B2 plus C1, C2 equals 0. Two planes are parallel. We have to check this condition. If this condition is true, we need to conclude that two planes are perpendicular. If this condition is true, two planes are perpendicular to each other. That is enough. Okay. Now, this is the condition A1, A2 plus B1, B2 plus C1, C2 equals to, we get 1 into 2, 2 plus 10 minus 12. So 12 minus 12 is 0. So two planes are perpendicular to each other. This is the concept of angle between two planes. We discussed the equation, the general equation of a plane, that is ax plus by plus cz plus d equals to 0, where a comma b comma c are coefficients of x, y, z respectively, and all are not equals to 0. That means the condition a square plus b square plus c square is not equals to 0. D is a constant term. Now, in this equation, we call a comma b comma c are dr's of the plane, direction ratios of the plane. Now, the normal form of a equation of a plane can be written as Lx plus My plus Nz equals to P. Here, L comma M comma N are direction cosines of the plane. What is the direction cosines? L can be written as plus or minus A by root of summation A square. M equals to plus or minus B by root of summation A square, and N equals to plus or minus C by under root of summation A square, where P equals to minus D by root of summation A square. This is a normal form of equation of a plane. And if L comma M comma N are direction cosines, it satisfies the condition L square plus M square plus N square equals to 1. Now let the plane equation be ax plus by plus cz plus d equals to 0, and the perpendicular distance from origin to this plane is d by plus r minus d by under root of a square plus b square plus c square. Now one more concept is the angle between two planes. The angle between two planes, what are the two planes? A1x plus b1y plus c1z plus d1 equals to 0, and a2x plus b2y plus c2z plus d2 equals to 0. We get an angle between two planes cos theta equals to a1 a2 plus b1 b2 plus c1 c2 plus d1, no, plus c1 c2 by under root of summation a square in a1 square under root of summation b1 square or a2 square. Both are same. If two planes are parallel, it satisfies the condition a1 by a2 equals to b1 by b2 equals to c1 by c2. If two planes are perpendicular, a1 a2 plus b1 b2 plus c1 c2 equals to 0. Now we solved some problems also. So intercept form. What is intercept form? Already we know that the general form of an intercept form learned in previous classes, x by a plus y by b equals to 1 in 2D geometry. In 2D geometry, d term is not there, z term is not there. X by a plus y by b equals to 1. We studied in 8th class, 9th class, 10th class intercept form. So we are discussing in 3D geometry. So one more variable is there, one more axis is there. So x by a plus y by b plus z by c equals to 1. This is the required intercept form. The equation on x by a plus y by b plus z by c equals to 1 is called the equation of a plane in intercept form, where x, y, z intercepts are a, b, c. A is the intercept of x intercept is a, and y intercept is b, and z intercept is c. These are the note points. You have to read it. So example, the equation of a plane whose intercepts on x, y, z axis are 1 to 4 respectively is. So put a equals to 1 and b equals to 2 and c equals to 4 in intercept form x by a plus y by b plus z by c equals to 1. So its LCM is 4. So you have to multiply first with 4. 4x plus 2y plus z equals to 4. So 4x plus 2y plus z equals to 4. This is the equation of the plane. So find the intercept of the plane. This is given plane equation. We have to convert this into intercept form. So first you have to write ax plus by plus cz equals to d. So this can be written as minus 2, dividing both sides by minus 2. So my x by minus 2, x by minus 1 by 2 plus y by minus 2 by 3 plus z by 1 equals to 1. So which is in the form x by a plus y by b plus z by c equals to 1. Here what is a equals to minus 1 by 2, b equals to minus 2 by 3, and c equals to 1. X intercept is minus 1 by 2, y intercept is minus 2 by 3, and z intercept is 1. So these are the examples. And this is one more concept.